25শে বৈশাখ। হে নূতন দেখা দিক আরবার, জন্মের প্রথম শুভক্ষণ। তোমার প্রকাশ কোহেলিকা করে উদ্ঘাটন, সূর্যের মতন ব্যক্ত হোক জীবনের জয়, ব্যক্ত হোক তোমা মাঝে অসীমের চির বিস্ময়। উদয় দিগন্তে শঙ্খ বাজে, মোর চিত্ত মাঝে চির নূতনের দিন ডাক। 25শে বৈশাখ হে নূতন। Welcome back. In my previous video I have seen the geometry of the power series. I have seen elaborately what is the radius of convergence of power series, what is the interval of convergence of power series, and how we will find the radius of convergence of power series and interval of convergence of power series by two tests, ratio test and Cauchy-Hadamard test. Today I will define this concept again just as a review. Today I will discuss actually some question based on this concept. Actually this concept very important for higher study. Okay, let's see my first question. Our first question is this. Here my question, which test would be applicable here? We can write this power series as n equal to 1 to infinity 3 times x minus 5 over n to the power n. Okay, therefore since here the power n, so here I will use just Cauchy-Hadamard test. What is the Cauchy-Hadamard test? We all of us know 1 over r, where r is the radius of convergence, is limit n tends to infinity supremum of absolute value of a n to the power 1 over n. Okay, since here absolute value of a n to the power 1 over n, therefore here we can apply the Cauchy-Hadamard test. First my question, what is the a n? n is whole term. Consider this is whole term is a. Now by Cauchy-Hadamard test, this would be limit n goes to infinity supremum of absolute value of 3 over n x minus 5 to the power n into 1 over n. Then this imply limit n tends to infinity supremum of 3 over n times x minus 5. Okay, and after putting the limit, this value would be actually 0. Since this limiting value is 0, therefore 1 over r equal to, this implies 0, that implies radius of convergence is infinity. And since radius of convergence is infinity, that means interval of convergence would be minus infinity to infinity. Okay, I hope my all viewers have understood why I will use here Cauchy-Hadamard test. Actually today's goal of this lecture is this: which test would be applicable? Consider this power series and what is the radius of convergence of this power series. But today's goal is actually which test would be applicable for this power series, Cauchy-Hadamard or root test. Since here n factorial, in which power series n factorial has given always I will use the ratio test. That means this is the shortcut trick. When you will see the power series has factorial, the notation factorial, then always I will use the ratio test. Notice here, by ratio test, limit n tends to infinity, absolute value of a n plus 1 over n. Consider this whole term is a n. That implies n plus 1 means n plus 1 factorial x to the power 3 times n plus 1, here factorial, times n factorial over x to the power 3n. Okay, that means this implies limit n tends to infinity x cube over n plus 1, and if you put the limit, then this value would be 0. All of us know this type of series convergence when this value less than 1. Since this value less than 1, then this power series always convergence, and for all values, since this value is 0 which is less than 1, for all value of x the power series convergence. Therefore radius of convergence would be infinity. Okay, and interval of convergence is minus infinity to infinity. Okay, similarly I will see another question. Notice here the series is n factorial times x minus 7 to the power n over 2 to the power n. Here also n factorial. So actually here I will use which test? Ratio test. See this question also. Limit n tends to infinity a n plus 1 over n. That means n plus 1 factorial x minus 7 to the power n plus 1 over 2 to the power n plus 1 times here 2 to the power n over n factorial x minus 7 to the power n, and this value is limit n goes to infinity, here n plus 1, we can write this 2 to the power n plus 1, that means 2 to the power n times 2, this value is 2, here x minus 7, because x minus 7 to the power n plus 1 means x minus 7 to the power n times x minus 7, this would be removed, so this equal to x minus 7, and this limiting value actually would be infinity. Since infinity always greater than 1, that means that implies this power series cannot converges, because one series would be convergence. The limiting value of the series less than 1. Since the value of limit is infinity, therefore this series cannot converge. Therefore, actually no value of x for which the series converges. Only there exists one value. When x equal to 7, then the limiting value would be 0. That means at the point x equal to 7, the radius of convergence means r equal to 0. Otherwise, the series does not converges. Only converges at the point x equal to 7. This type of question actually I have defined in my earlier lecture. So at first I will highly recommend you, if you don't see my previous video, at first see my previous video, then today's video would be so easy. Our next example, consider this power series. Which test applicable here? At first thing, when the series is look like a to the power n, n factorial, then always I will use ratio test. since here n over 4 to the power n, so here also I will use ratio test. Limit n goes to infinity, n plus 1 over 4 to the power n plus 1 times 4 to the power n over n, x minus 3 to the power 2n plus 1 over x minus 3 to the power 2n. Therefore, here absolute value, this implies limit n goes to infinity, here n plus 1 over n, here 4 to the power n plus 1, 4 to the power n, this would be cancelled, that means this would be 1 over 4, this just out this part in here, here x minus 3 to the power 2n plus 2, here x minus 3 to the power 2n, this here absolute value, then this value would be, always notice this value is 1, limit n tends to infinity, n plus 1 over n, always 1, that means this value is 1 over 4, and here x minus 3 to the power 2. Therefore, we all of us know this series convergence when this value less than 1. That imply x minus 3 whole square less than 4. That imply x minus 3, here absolute value. Absolute value of x minus 3 less than square root of 2. Sorry, here square root of 4. And square root of 4 actually nothing but this is equal to 2. That means here the radius of convergence is 2. Okay? Therefore 2 is the radius of convergence. What would be the interval of convergence? That implies absolute value of x minus 3 less than 2. That implies x lies between the interval 3 plus 2 comma 3 minus 2. Therefore, x lies between the interval 5 comma 1. In this interval, the power series always converges. We'll see at the end point 5 and 1, is the power series convergent? At first, I will check at the point x equal to 5. That implies series n over 4 to the power n times 5 minus 3 to the power 2n. That implies series n over 4 to the power n times 2 to the power n. This is equal to actually n over 4 to the power n times 2 to the power 2n means 4 to the power n. Just omit this part, that means this is actually the series n. And this series n always divergent series. So, at the point x equal to 5, the series cannot convergence. Now I will say at the point x equal to 1. At the point x equal to 1, the power series reduces. Series n equal to 1 to infinity n over 4 to the power n minus 2 square to the power n. Since here the square, that means this would be 4 to the power n. Just cancel 4 to the power n, that means this is this. This implies this. Always this series is divergent series. Therefore, similar to before, x equal to 1 not applicable here. So, only this interval, for this interval, this power series is convergent. Okay? Our next question, find the radius of convergence and interval of convergence of this power series. Notice, here also I will use the ratio test because here 1 over n square. When I will tell you when the series look like 1 over n to the power p, then always I will use the ratio test. Like ratio test, here this is an. Limit n tends to infinity, an plus 1 over an, that means 4x plus 1 to the power n plus 1 over n plus 1 to the power n plus 1 times n square over 4 plus 4x plus 1 to the power n. Here this is very easy. Limit n goes to infinity, n square over n plus 1 whole square times omit this portion, this would be 4x plus 1. Okay, and this value is obviously this value, limit n goes to infinity 1 plus 1 over n whole square, obviously this value is 1, therefore that imply this is 4x plus 1, and this power series convergence when this value is less than 1. We can write this as 4 times absolute value of x plus 1 over 4 less than 1. That imply absolute value of x plus 1 over 4 less than 1 over 4. That means obviously radius of convergence of this power series is 1 over 4. Then what is the interval of convergence of this power series? Okay. In here the center of this power series is minus 1 over 4. Therefore, interval of convergence of the power series is convergence of the power series is absolute value of x plus 1 over 4 less than 1 over 4. That imply x between minus half comma 0. In this interval the power series converges. Is the endpoint would be included in this power series? For this, at first check at the point x equal to 0. When x equal to 0, then the power series reduces 1 over n square. Obviously, we all of us know this power series, this type of series always convergent. Therefore, in the interval of convergence, 0 would be included. Now I will say at the point x equal to minus half. When x equal to minus half, then this power series reduces 4 times minus half plus 1 over n square to the power n. This implies the series n equal to 1 to infinity minus 1 to the power n over n square. Obviously, by Leibniz test we can tell this power series is always convergent series. Since this power series is convergent, therefore, in the interval of convergence of this power series, minus half also included. Minus half also would be included. That means interval of convergence of this power series is minus half to 0. I hope my all viewers have understood what is the geometry of the power series, how we have to find radius of convergence of power series, how we have to find interval of convergence of power series, and which method would be applicable to evaluate radius of convergence of power series. Example, the power series minus 1 to the power n x to the power n over 4 to the power n log n. At first my question, which test would be applicable here? Here, for 4 to the power n, my all viewers have understood, here ratio test would be applicable. But for log n also I will apply the ratio test. That means, from this power series, we have understood in which power series log n given, there exists also ratio test would be applicable. Absolute value of n plus 1 over an. Limit n goes to infinity, absolute value of an plus 1 over an. This is an plus 1 over an. Here would be 4 to the power n plus 1 log of n plus 1. Here 4 to the power n log n here x to the power n plus 1 over x to the power n, here absolute value. That means this is equal to limit n goes to infinity 1 over 4 log n over log n plus 1 x. Okay, that means this is 1 over 4 limit n goes to infinity log n over log n plus 1 absolute value of x. Here was 1 over 4 mod x limit n goes to infinity log n over log n plus 1. Here I will apply the L'Hospital rule, infinity by infinity. For this 1 over 4 log a, absolute value of x limit n goes to infinity 1 over n, here 1 over n plus 1. Okay, this imply 1 over 4 absolute value of x limit n goes to infinity n plus 1 over n. Whereas this value of limit is 1, therefore this value is 1 over 4 mod x. And we all of us know this power series converges when this value less than 1. That implies absolute value of x less than 4. Therefore, radius of convergence of this power series is 4. Now I will say what is the interval of convergence. Interval of convergence is minus 4 to 4. Now I will see is the endpoint applicable for this power series. First I will see at the point x equal to minus 4. In this point the power series reduces minus 1 to the power n, minus 4 to the power n, here also 4 to the power n log n. Then this series is here minus cancel out, 4 to the power n, 4 to the power n log n. That means this is represent as 1 over log n. And we all of us know this series is divergent series because log n less than n for all n greater than equal to 2. Therefore 1 over log n less than 1 over n, and this series is divergent. Therefore by comparison test we can tell this series is divergent series. Therefore at x equal to minus 4 this series is divergent. When x equal to 4 then this imply minus 1 to the power n, 4 to the power n, 4 to the power n log n. This would be cancelled. Then this imply minus 1 to the power n log n. At this test we can tell this series is convergent series. Therefore at x equal to 4 this series is convergent. Therefore here the here would be close interval, that means open interval minus 4 to close interval 4. In this interval the series is convergent. Okay? Oh wait. Yeah, I will stop here. In my next video I will discuss Taylor series and I will discuss new function, analytic function. But at first I will highly recommend you please see today's video with pay attention. Then you will understand in better way my next video. See you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.